Hello students, very good morning. Welcome back to Physics Marathon, and we are here again for the AIATS Plus Phase 2, and that is for a discussion of the committed mistakes, what you people have attempted wrong in your AIATS Plus mock test 3 that happened on 2nd February 2025. So welcome back to this show. Myself, Puneet Kathuria, your physics faculty at Aakash. So, shall we begin the session? Okay, thank you. So, let's begin the session. So, today's session revolves around again all these topics, what all will be discussing primarily, what all will be focusing in this episode of your physics marathon. This is regarding your electric charges and fields, electrostatic potential and capacitance. Then we have units and measurements, motion in a plane, and finally mechanical properties of fluids. So these are the prime areas what we'll be focusing in this session. So let's start with some of the numericals where you people have committed few mistakes. So let's understand these concept by concept. Let's build up their concepts and solve these situations. Now the very first question, a physical quantity A is related to 4 other physical quantities A, B, C and D as follows. So your situation is something, so your physical quantity A is related to A, B, C, D, like A square B cube by C times root D. So I am writing root D as power 1 by 2. So the percentage errors of measurement in A, B, C and D are 1%, 3%, 2% and 2% respectively. What is the percentage error in the quantity A? So this is a very standard question which have been asked in your NEET PYQs also. So this is very important and we have been dealing with these kind of situations very oftenly. So let's attempt this. So I am giving you first the relative error before we move on to the percentage error. So if I put it like this, delta A by A. So this is your relative error in A. So look at the power of small a, and that is 2. So this is 2 times relative error in small a. So this is the first step. Second one, look at the power of B, that is 3 times delta B by B. So this is the second step for this. What is the power of C? Power of C is 1, so that would be 1 times delta C by C. And look at the power of D, so that is half times delta D by D. So this is the standardized formula for your relative error. Now the question is regarding your percentage error. We know if you multiply this, I mean like the whole equation with 100, so every term will get multiplied by 100. So what you will end up with, so this is delta A by A into 100 and 2 times delta A by A into 100 plus 3 times delta B by B into 100, then 1 time delta C by C into 100 plus half time delta D by D into 100. So when you multiply the whole equation, both the sides by 100, So this becomes percentage error in A, and that is equal to 2 times percentage error in small a, and that is 3 times percentage error in B plus 1 time percentage error in C plus half time percentage error in D. So this becomes a standardized formula in terms of percentage error, and this way what we'll be ending up with will be having the maximum error in physical quantity capital A. So I hope we people have understood this much. If you have any doubt, or this is a very standardized question which we have been repeating number of times in our previous sessions also. So I think by this time, with this attempt, you people would be definitely getting 4 out of 4 in your NEET exam if you come across this same variety of question. So let's work out the actual answer for this. So shall we move? So let's write down. So your physical quantity was a square b cube c times d power 1 by 2, and we have just noted it down. Percentage error in capital A is 2 times percentage error in small a and 3 times percentage error in B plus 1 time percentage error in C plus half time percentage error in D. So this is a standardized formula. So I think all these percentage errors in the individual quantities 1, 3, 2, 2 is given to us. So this is 1%, this is 3%, and in C we had 2%. In the last D also we have 2%. So we have just substituted the values whatever is given in your problem. So let's multiply this and finally add up with all this. So this becomes 2, this becomes 9, this becomes 2, and finally it becomes 1%. So in totality what you will get 11 to 13 and 14%. So the final answer for the percentage error in physical quantity capital A, and this is 14%. So I hope we all have got this concept very well, and I am again repeating this, the very same concept. This kind or this variety of question have been asked in your PYQs earlier also. So this is a very important, very standardized format. So please understand it, and if you have any doubt, you can still confirm it. Or please allow me to move ahead. So we have one viewer, Parnika. Sir, is it necessary to read NCERT? There is no doubt when you ask for your NCERT, because we know all the exams, be it your board exam, be it your NEET exam, the reference for all these exams is NCERT. So it is always good and advisable, and rather this is necessity for all of us to at least go through the Bible that is given to us as NCERT. So yes, this is highly recommended, and you must go through each and every line, each and every part of your NCERT very well. So I think with this we should move on. Shall we move? Any doubt? Okay, fine. So let's continue. Yes. So the next question is again, and I would like to highlight this question: if mean scale division of screw gauge. So screw gauge is a very important concept for your measurement part. It comes in your measurement, units and dimension, and simultaneously this is from a section that is additionally recommended to you as the experimental skill. So this screw gauge and another vernier caliper, they both belong to experimental skills part also, and that is important for your NEET syllabus also. So this is screw gauge. So screw gauge, the main scale division of screw gauge is 1 millimeter, and there are 100 division on circular scale. Then the least count of the screw gauge is. So first, I think most of you understand this word least count. So if you understand it well, so this is basically understood as this is the minimum measurement. That can be obtained using any measuring instrument. So basically this definition is a very standardized definition. What you can measure, the minimum recording, what you can have it using that particular instrument, be it your vernier caliper or your screw gauge, that minimum recording that we can have it from that particular instrument, that is called the least count. Now here we are talking about screw gauge. So please understand what is basically the formula for the least count of your screw gauge. And this least count, what I am writing it as LC. So this is, you can write it down as mean scale division, and you know sometimes this mean scale division is also known as pitch also, divided by number of divisions on your circular scale. So this is a very basic and standard formula that is there for your least count of your screw gauge. So just remember this formula, because this formula will help you to solve good many number of numericals. So yes, we have got an answer from one of the student, Shinchan Nohora, 0.01 mm. So let's verify whether he is right or not. So what is mean scale division? What is the mean scale reading given to you as? This is given to you as 1 millimeter. And then your question says there are 100 divisions on circular scale. So number of divisions on circular scale is 100. So for this screw gauge, so this is the least count of your screw gauge, given screw gauge, and this is 0.01 mm. So this is the correct answer, we have it. So any doubt? Any doubt? So I hope we have understood this part also. So shall we move? So yes, Dashrath, how are you? So very good morning. Manas Singh, good morning. Mukesh, very good morning. So any doubt? Otherwise, please allow me to move forward. Fine. So if there is no doubt, let's move to the next question. Next question is also quite interesting, and this is again one of the standardized format for your NEET, one of the important formats, and This kind of question have also been asked in your previous year questions also. So let's understand. The equation of projectile is given to us as root 3x minus gx square by 2. The angle of projection with the horizontal is, where x and y both are in meters. So let's understand. So we know, if I define your projectile something like this, and if you project this particle at an angle theta with respect to horizontal with speed u. If I ask you to observe your particle or your projectile at any of its trajectory, just by looking at the trajectory, can you give me the answer for what kind of shape it appears to be? What kind of shape this projectile is following? So yes, you can see it as a parabolic path. So this is the parabolic trajectory. So we could have derived it, but otherwise for this situation I am using the direct equation of, so I am using word equation as EQN. So your equation of trajectory. Trajectory is basically the path followed by your projectile. So what is the equation? So your equation is y is equal to x tan theta minus half g x square by ux square. So this is a standardized equation of trajectory, and I would rather suggest you, this is one of the important formats. So why don't you write it, and why don't you, retain it? Why don't you memorize this formula also? Because this way you people would be able to solve good number of numericals in the minimum possible time. That is what you call it as the shortcut way. So this is a standardized equation of this one. So this is one. If you allow me, I can give you one more standardized equation of this, the very same. We can adjust it, we can solve it. So this is x tan theta minus x by r, where if ux is your initial horizontal component, r here refers to the range of your projectile. So everyone understands this is your range. So I hope we people now are well familiar with this equation of trajectory, and these are the two standardized equation of trajectories. So I am again emphasizing, this is very, very important format. So why don't you remember these two formulas for the equation of trajectory? Quite easy formulas to retain. You just need to put it in writing maybe once or twice, and finally if you need to solve the numerical comparing it with the first one, so let's understand it. Now if you again standardize it like this, or if you compare this equation with the given equation, if I am writing the given equation as root 3x minus gx square by 2. So this is the given equation in your question. Now you compare this equation number 3 with the equation number 1. So what you observe, so when you compare it, on comparing, can you see, shall I write down root 3 as tan theta? One thing. Second thing is 2ux square. If you just look at this, so this is equal to this 2, and that way we can solve it from all the angles, whatever is being asked to give it to you. So in this question, the question primarily is asking about the angle of projection. So we have to solve for this theta. And I think we have already got the answer just by comparing your given situational problem with the standardized equation. So when you compare it, so what you will end up with? Everybody is well aware of it. Tan 60 degrees equal to root 3. So this is the required answer because this is what is being asked from you, the angle of projection. So this is 60 degree. And if you compare it like this, so I think ux we can easily write down as 1 also, though this is not a part of your question. So this is something additional for you. So I hope if you remember these two standardized equations of equation of trajectory, you can solve at least varieties of numericals. So any doubt? Any doubt? Yes, we got a right answer from Poonam. So good, Poonam. So you are right, it's 60 degree. Shall we move, or shall I give you one more problem based on the same? I think we should attempt. We should go for one more. Now let's suppose if equation of trajectory is given to you as maybe ax minus bx square. A very important format, and you can find this format again in your PYQs. Now, so this is the equation of trajectory for a projectile. Now question is, you have to find out the range. In the last numerical, you were asked to give me the angle of projection, but this time it is the range. So you are supposed to give me the range. Now, there are two ways. One way we have already understood it just by comparing it with the standardized equation. Second way, we can put it like this. So if you look at this, so this is the equation of your, this is your basically parabolic trajectory, and equation of this projectile is given to you as, this is a downward parabola as the equation itself suggests you. Now look at this point. If you look at this point is basically referring to your range starting from this, from the point of projection. Now one more important point, if you look at the coordinates of this point where the projectile is finally landing, if I ask you to write down the general coordinates, so we always put it like, because this is the 2D motion, so we simply write it as x comma y. So your x is basically referring to your range, and y coordinate for this is 0. Don't you understand? This is again one of the easiest formats we have to solve this kind of question. So now this is the concept I am going to apply on this one. So you are saying y coordinate is 0. So shall I put y coordinate in this situation as this equation as 0, and this is equal to ax minus bx square. So it means ax is equal to bx square. So 1x goes with this x, and a by b is your x. And what x refers to you? X is basically your range. So your question was to give me the value of range, and that is a by b. So this is again one of the easiest formats to understand this variety of numerical we have. Any doubt from this part? Sure? Yes, Lavina, good morning. I hope you people are getting it very well. If you have any doubt, you can still refer to this, or you can ask me right here in this session only. Shall we move? Okay, fine. So I'm moving ahead. Yes. So the next question is, 2 point charges Q each are located at the points minus a comma 0 and a comma 0 respectively on x-axis. Total electric potential at the origin is. So this is something. So they are asking you electric potential. So let's again build up the concept for this electric potential. So we write down electric potential as V, and for a point charge we simply put the formula for the electric potential as kq by r. And what is this? Is this a scalar or a vector physical quantity? Anyone? Is this a scalar or a vector? Okay, so this is a scalar physical quantity. So important point to be noted here is this is a scalar physical quantity, and if I ask you the units and the dimensions for this, this is quite interesting. So this is basically defined as work done in bringing a positive test charge from infinity to that particular point. So this is work done per unit charge. So SI unit work done is in joule, charge is in coulombs. So that is, and the dimensionally is ml square t minus 2, that is for the work done, and coulomb is charge. So charge is A into T, and that gives you primarily the concept. So this is what. Now let's come back to the same question. So we have a configuration. So let's build up the concept. So this is your origin. So this is origin. We have, this is 1 point. So that 1 point is a comma 0, and second point is minus a comma 0. So these are basically the coordinates of the 2 points where you have 2 point charges. So what you have placed? Q and Q. So this is the configuration, and they are asking you what? Potential at O. This is, let's label this position as 1, this position maybe as 2. So here we have to give the final potential at O. Now first of all, how many charges are around point O? So if you can see, we have 2 charges. We have labeled these 2 positions as position 1 and position 2. So if you have 2 charges, it means primarily you have a potential from both the charges. So this is due to charge at 1 and potential due to charge at 2. So this is what you have to give me. Now potential being a scalar quantity, this is important one. So what is the potential of charge 1? So that is k q by r, and can you see this r as A? So this is the one. This is just a separation. So whenever you just look at the concept as scalar and vector, so you have to just look at the numerical value. You don't have to consider the, like this is minus A. So most of the students, what they do is they simply put it as minus A, which is wrong. So this is just a separation. So we'll always take it as a scalar one. But definitely for the charges, they do participate. For the charge 2, potential is again positive, and that is also kq by A. And this is the net potential. And finally, what you will have is 2 kq by A as your answer for this net potential at the origin. So shall we put it? So what is the best option? The correct option rather is 2 kq by A, where everyone understands what k stands for. So if I write down k as your 1 by 4 pi epsilon naught, everyone understands this part. So this is a constant of proportionality, and numerically this k is 9 into 10 raised to power 9. So we can calculate the numerical value of potential also if these two charges are given to us in numerical values. So we can have the final answer in the numerical value also. But this is a generalized concept. So I think I have managed to make you understand how we have to approach. Now let's make a twist of the same, if you allow me. So yes, Manas Singh has again a question, so I am coming to the same concept. So let's suppose we have the same origin and we have the same coordinates as a comma 0 and this is minus a comma 0. Now instead of placing both the charges as positive, so let's place this charge may be positive, this charge may be negative. And you know, when you have these two equal and opposite charges, they are separated by some distance. So what you call this system or arrangement as? Electric dipole also. So let's come to the same. This is your point O, and again we have to find out net potential at O. So that would be contributed by potential due to these two charges. So here we have position 1 and we label this position as 2 again. So what is the potential? Can you see the charge at position 1 is negative, and because of this negative charge we have a negative potential. So this is where you have to be very particular. So potential is K Q by A numerically, but because charge Q is negative at position 1, so we'll simply write it as minus KQ by A, and for the other one, so that would be KQ by positive A, and this way when you add it, so for this configuration the net potential comes out to be 0. So I hope we have understood this part also. Any doubt from this part? Yes, so I think I have managed to answer GS Aishwarya also. So if Q is negative, we should consider sign, sir. Yes, so we have taken that example. Anything else? I think we should move on. Now we have a next concept. So what this concept is, two particles carrying charges 1 microcoulomb and 2 microcoulomb separated by a distance d apply force F on each other. If charges of particles are doubled, then force of repulsion between them is. So bachcho, this is also very interesting situation and very easy. So let's build up like this. So you have two charges, Q1 and Q2. They are separated by this separation R, and they are assumed to be in vacuum or free space. So what is the force between these two charges? Shall I put it as K Q1 Q2 by R square, where Q1 is given to us as 1 microcoulomb and Q2 is known to us as 2 microcoulomb. But we'll keep it in a very standardized general format only. So this is the force. So they are separated by distance d. So if you specifically put the values, so this is the first expression as per the given statement. If charges of the particles are doubled, it means you are doubling both the charges. So it means you are doubling, it means you are making this charge as 2. So 1 becomes 2 and 2 becomes 4. And you know, nothing is commented on the separation or anything else. So rest of the parameters will keep same. So it means they are again separated by, and this is the new expression for the force. Let's call this as F prime. So we need to find out F prime in terms of F. So what you do is you simply divide these two, and when you divide these two, so this d square, this k, everything goes. This 2 goes with this. This is 4 times. So if I put it like this, so F by F dash becomes 1 by 4. So this is the expression what we are looking for. So F dash becomes 4F. So this is quite interesting. Now, if I add on one more point to it, if I ask you what is the percentage increase in force. So this question can be, I'm like asked in another format. So if I ask you what is the percentage increase in force, we know the new force after doubling the charges will become 4 times. But what is the percentage increase? So whenever this is there, percentage increase in force, so we always keep it like this, the change in force by original force into 100. And if you follow this, F dash is 4F minus F by F into 100, and this 4F minus F becomes 3F. 3F, FF goes with this, and this is 300%. So I think if they ask you the percentage increase in force, so now you got how you will find out or how you will calculate the increase in force. So any doubt from this part? So shall we? Fine. Now, this is again interesting area. This is from the capacitor part. A capacitor of 20 microfarad is completely charged with a battery of 50 volts. After disconnecting this capacitor is connected with another identical capacitor, the common potential of the combination will be. So we have a capacitor. So let's understand it. Let's build up the concept. So we charge it. This capacitor is C1. Let's understand it. And we just charge it to a potential V1. So what is the initial charge? This is Q1. And let's assume this is positive plate, this is negative plate. Got it? And we just remove the source of the battery, and this is the condition. What is the energy stored in this? That is this one. Got it? Now we have another capacitor, and this is capacitor 2. Let's raise it to potential V2, and charge stored on it would definitely be Q2. And this is again the positive plate, and that is the other side is negative plate. So what is the energy stored individually in this second capacitor is this one. You got it? Now let's join these two together. Important point, you are joining positive plate with the positive plate. Do we understand this? positive plate with the positive plate, but because of potential difference, there would be some rebalancing of the charges, and configuration would be like, so the new charge is Q1 dash and Q2 dash. This plate would still be positive, this plate would still be positive, but because initially they had a potential difference, so they exchange the charges till they attain a condition of common potential. So capacitance, that is C1, and that is irrespective of its potential or source applied. It depends only on the configuration, we understand it. So the common potential would be V. So they both attain the same potential, and this is the final charges. So this is one. Now as per your conservation of charge, so I am writing conservation of charge. So conservation of charge says the initial charge on the system is Q1 plus Q2, and the final charge of system is like this. So here we are writing C1 V1. If you look at this, this is C2 V2, and this is what? C1V plus C2V, and here we'll keep V as common, so this becomes C1 V1 plus C2 V2 by C1 plus C2, and that gives you the expression for the common potential. So I hope this is something interesting, we have got it. Now let's come to the question. It says a capacitor C1 is given to you as 20, completely charged with a battery of this 50 volt. So if I put simply the values in this, so C1 is what? 20 microfarad, and V1 is what? 50 volt. Now after disconnecting, this capacitor is connected with another identical capacitor. They are not saying the identical capacitor is charged or raised to any potential. So V2 part, that is 0, and so this part completely vanishes, divided by C1 plus C2. So because we have an identical one, so this is 20 and the other one is also 20, so that makes it 40. You got it or not? And when you solve it, what you will end up with? You will end up with 25 volts. Yes, 25 volts. So that is the answer. We can find out the loss in energy also. If I give you the expression for loss in energy when charges are being exchanged just to attain the common potential. So what is the initial energy? Initial energy was, this is being carried by your capacitor 1. This is by capacitor 2. And what is the final energy? Final energy is half C1 plus C2 into common potential square, V square. And if you put the values of this one, without wasting much of the time, I am giving you the direct expression that you can easily solve. So this is the final expression for the energy loss also. So if they ask you the energy loss, we can find out the energy loss also, because C1 and C2 both are given to you as 20. V1 is given to you as 50, though V2 is 0. So just by calculating, just by putting all the values in this expression, final expression, we can solve it for the energy loss when charges are being exchanged between these two capacitors just to attain the common potential. So I hope we have understood this part also. So shall we move? This is something interesting. Consider a U-tube with liquids filled inside as shown in the figure. If the system is at rest, then the value of H will be approximately. So we have to understand the figure. So there is a mercury, then we have one type of oil, then we have another, that is glycerol. So this is the one. So again, this is very interesting format, and just to solve this, you have to apply a basic principle, and that is your Pascal law. So this is based on your Pascal law. So what Pascal law says? It says if you have a liquid, all the points within that liquid, all the points which are at the same horizontal surface, in the same horizontal plane, they will have the same pressure. This is the important statement of your Pascal law. So that law will be applying directly to this numerical. So we have to first find out or look for these 2 points where pressure is same as per your Pascal law. So I think we can have these 2 points, because important point to be noted, these 2 points should be at same level, should be within the same liquid. So these are the points we are considering that these 2 points are there in the same liquid, that is mercury. So let's label this point as A, label this point as B. So we have understood the concept, we have understood the statement of the Pascal law. Now we are going to apply that Pascal law in this numerical, and this is one of the beautiful numericals we have. And this numerical, this variety of numerical have also been asked in your PYQs, previous year questions. So this is one of the important questions. So I would rather suggest you, if you are carrying something to write, please note it down. So Pascal law says these 2 points are in the same liquid at the same level. So pressure at point A is equal to pressure at point B. These 2 tubes are open. So on both the sides we have atmospheric pressure. So that is also there. So now look at the pressure exerted by the liquid column. We understand pressure exerted by liquid column is given to you as H rho G, where H is the height of the column, rho is the density of the liquid, and G is your acceleration due to gravity. Now, what is pressure at point A? So if I put pressure at point A as P naught plus pressure due to this oil. So this is height of the oil, density of the oil, into G. So this is the pressure at A. Got it? So we need to equate it with the pressure at point B. So what is the pressure at point B? Look at this, P naught is there. Then height of glycerol, density of glycerol into G, plus then there is another height, and that is of your mercury. So height of mercury, density of mercury into G. So once you have written down these 2 pressures, you have to just equate it as per the given statement of your Pascal law. So this P naught goes with this P naught, so that vanishes. It makes no difference. Then let's cancel these two G's also on both the sides. So what you are left with? Height of the oil. Can you see the height of the oil as 20 centimeter? So let's put it as 20 centimeter. Then density of the oil. What is the density of oil? That is given to you as 0.8. This height is in centimeter, density is also there in the CGS system. So there is no harm. Keep the CGS system intact. And that is equal to, on the right hand side, we have height of the glycerine or glycerol. So what is this? This is H. And what is the density of glycerol? That is given to you as 1.3 plus. Now when you look at these two sides, so if this is 20, this H goes. So what you will end up for this height? This is 20 minus H into density of mercury is given to you as 13.6. Once you have this equation, and this is quite simple, Pascal law. Once you have this equation, it's only the numerical calculation you have to make, and you have to find out the value of H. So let's do it. This is 16. This is 1.3 H. When you multiply this with this, that gives you 272 minus 13.6 H. And then that way you have to calculate your H. So what this H is there? So this is 272 minus 16, and on this side 13.6 minus 1.3. So this is 6, 5. So this is 256, and this is 3. This is 12.3, and when you solve it, it gives you close to 20.8 centimeter. So this is the height you have to find out for the glycerol, and this is 20.8. This is the finest question we have in the whole discussion of this session of your physics part. I must say this is very important format based on your Pascal law, and one of the best questions we have in this episode of your physics marathon. So I hope you have understood this part. Any doubt from this part? Any doubt? Shall we move? Shall we? Sure. Now, the next question is from your projectile part. What this says: the ratio of ranges of projectile motions with angle of projections 30 degree and 60 degree is the ratio of ranges. So this is one projectile projected at an angle theta. We can write down as simple theta also. So this is with respect to horizontal. And if I ask you the range for this one, so we know the formula for the range, u square sine, this is u square sine 2 theta by g. This is the one. And if I give you another projectile, this is projected with the same speed what you had it in the first case. So but this time we simply keep theta with respect to vertical, or if theta is with respect to vertical, what is this angle is? So I think this angle is 90 minus theta. So this is 90 minus theta, but again with respect to your horizontal. Important point to be noted, these two projectiles have to be thrown with the same speed u. So what is the value for this range in the second case? So do we remember this theta initially when you had it for the range? This is with respect to horizontal. So this is u square sine 2. But this time angle with the horizontal is 90 minus theta by g, and this gives you u square sine 180 minus 2 theta by g. And in trigonometry, we understand sine 180 minus 2 theta as sine 2 theta only. So this also gives you u square sine 2 theta by g. So now when you compare this R1 with this R2, what do you observe? For two different, these two ranges come out to be same. It means, can we understand it? This is for the complementary angles. If one is theta, the other angle is 90 minus theta. So for these two complementary angles, the range or ranges for these two projectiles projected with the same speed u is same. So here we have angle of projections as 30 and second one is 60. Are these complementary angles? Yes. So I think we have already got the answer. So one is theta, one is 60. So the ratio should be 1:1. I hope we have made it clear to you. Any doubt? You can still confirm it. Manas has given the right answer as 1:1. So I think we should move on. A particle has initial velocity and a constant acceleration. The velocity of the particle after 2 seconds will be. So this is to do with your motion in 2D, and this is a uniform accelerated motion. So let's frame the given situation as, what is the initial velocity along x-axis? That is given to you as what? 4. What is the initial y component? That is 6. So this is the given information. Now it is being acted by an acceleration. So what is the x component of the acceleration? This is 1 meter per second square, and y component is also 1. And they are asking us the velocity of the particle after 2 seconds. So time is given to you as 2 seconds only. Velocity. So this is clearly a case of two-dimensional motion. So, and this is a uniform accelerated motion. So can we apply the equations of motion for the uniform accelerated motion? Yes, we can. So using the equation v is equal to u plus at. So let's study these two components separately. So this is ux plus axt. What is ux? Ux is 4. What is ax? 1. Time is 2. So that makes it 6. So if I precisely put x component, so shall I put it like this, 6 cap. Similarly, if I do it for the y component, so using the same equation, let's put the value for the given situation, the y component. So this is 6, ay is again 1, time is again 2, so you will end up with 8. This is y component. So velocity. Now velocity being a vector quantity, so we have to keep it in the vector notation only, and we'll keep it as 6 cap rather. So this is 6 cap plus 8j, and standardized units as meter per second only. Any doubt from this part? Shall we Yes, probably this is the last numerical of the day for this particular session. 3 charges, plus q, and minus q. So look at the position of the charges placed on the circumference of a circle of radius r. The force on plus q charge placed at the center. So we have to find out the force due to all the 3 possible charges. So let's attempt it in the minimum possible way. So this is the charge 1. So because of this, shall I call this force as F1? And this is towards x-axis that is given to you. So shall I put it as F1 as a vector? And this force is what? K. This is between charge capital Q, small q, and the separation is r, that is the radius, and this is along I, that is along x-axis. So this is the first force. Can you see this force as F2? This F2 is along y-axis, so let's keep it again in the vector form. This is again between the pair capital Q, small q, so this is the one, but directed along y-axis, so shall we keep it as J? Then there is another force F3. Now look at this, because this charge and this charge, both these charges are positive, so that is why we have a force away from this. But look at this charge, this being a negative, so this will attract, and we have another force, that is F3. Look at the direction of the F3. And this is between the pair plus q and minus q. And direction of F3 is because of the negative nature of minus q. So F3 in terms of magnitude k q by r square, and this is also along x-axis if you look at this. So what is the resultant force? Resultant force is simply the vector sum of all these. So this is F1, F2 and F3. As per your superposition principle, this is the resultant force. So F1 and F3 both are along I, same in magnitude. So let's simply put it like this, plus J as such will be there, and this is the resultant force we have. So let's check the expression, 2kq small q by r square this, and this is, yes, option 2 is the correct option. So I hope I have made it clear to you with this in the simplest format, understanding this concept in like the superposition principle. Any doubt from this part, or shall we move? Good. So this is all about from my side, myself Puneet Kathuria, your physics faculty at Aakash Institute. So this is all from my side for today's physics discussion. So let's wait for the next episode to begin very soon. So by the time, I must say thank you for attending this session, and see you next time with the more concepts. Till then, bye, take care. Thank you. Thank you, students.